first line of the recording. It's like, I'm always accused of not having bottoms. And we're back. All right. Oh, you'll appreciate this, Dover. So my my workout routine in the winter, so I don't blimp back up during the winter, is I moved an exercise bike near one of my iMacs, and so I ride the exercise bike while playing a game of Hearthstone.
Nice.
So a game of Hearthstone, it averages between 3 and 5 miles on the exercise bike. Closer to 5 miles with the current.
Playing control decks, and then it'll be
Well, I play kind of a control deck mage, anyways. But the current was the brawl.
Oh, the brawl.
Yeah, it's like super slow right now.
Mm-hmm.
That the match just goes forever.
Yeah.
So I did 8 miles on a match the other day and lost.
Ooh.
That's what I hate about the brawl right now. Like you feel like you're in control, everything's going fine, you're gonna win this thing, and all of a sudden you just get destroyed.
Yeah, because they have like 4-0 cost spells.
Yeah, but it's kind of fun.
Yeah, it is.
But yeah, so it's a good workout. The current tavern brawl.
Well, it kind of fits, tavern brawl.
That's right. Okay, so let's pick up where we left off. We were talking about various thread libraries, right? All right, so we're talking about kind of the details of our how CPU scheduling works now, kind of at the 10-foot view, if you will. So we talked about some various threading libraries, whatever. Let's just say they're all equivalent. It's all kind of a crapshoot with operating systems, right? Where we're trying to play this balancing game over which is faster than something else, and it all depends on how the user actually uses the system and that type of stuff. So and actually, kind of an interesting aside to this. I don't remember the exact example, otherwise I'd show it to you, but when I was in grad school, taking a computer architecture, it was like a second level computer architecture class, we had this example where adding more memory to your computer actually made your computer slower. So, was that just a meow?
No, I was very confused.
Huh?
The Samsung 128 gig sticker RAM.
Yeah, they're starting to mass produce Samsung 128 gigabyte stick of DDR4 RAM.
Okay. For like laptops or desktops?
Yeah, just for like consumer use.
Well, that seems to be a very strange jump.
No, I didn't see it coming, but yeah, 128 gigabytes. Let's go.
You can actually, as far as I knew, you couldn't even get 16 gig sticks. You can get dual 8s. But I think 16 gigabyte sticks is, so they just, huh? No, RAM for your computer.
Okay. Randy, that just blows you out of
Yeah.
water.
Yeah, I mean the biggest you could get was the biggest you can get was 8s, right?
Yeah.
Yeah, so
So
we're gonna skip it. We're gonna skip 16s and 32s and 64s and just go right to 128s. Sounds expensive.
I'm sure. I didn't see a price tag. I don't think they had announced a price tag, or at least the article I read didn't have.
My guess is I'm gonna say
$1 for, or $10 for each gig, right?
I'm gonna say it's gonna be $2,000
$2,000.
out the door initially for a 128 gig stick. You might find some deals for dual 128s.
For 15.
Yeah, right. But now you got to find a motherboard that can accept it.
Yeah.
It's only desktops.
What?
Like how many DDR4 motherboards are there?
Well, it should still clock down. So I think even a DD3 motherboard probably will detect it. But and actually, it's not the motherboard. It's finding an operating system that'll address that much RAM. Because even just a few years ago, you had problems with, well, more than a few years ago now, but like Windows Vista, when it came out, if you had 8 gigs of RAM in your machine, which wasn't necessarily unheard of then, it could only address 3.5 gigs of it unless you did the 64-bit version of Vista. Well, the 64-bit version of Vista wasn't ready for real time at this point. So you really had to run the 32-bit version of Vista if you wanted to have a fighting chance at stability. Then you only got to use half your RAM on that side of things. So it's kind of, so I would doubt that any, I mean, I don't know if nobody talks about it, right? But I would doubt that there's any operating system today that addresses 128 gigs of RAM or 256 or 512 for that matter if you have 4 slots.
They're saying that it's really for servers, and that if you buy their new server, you get 12.2 terabytes of RAM.
What?
I just read
Hey, hold on. That can't be.
Yeah, I just read
12.2 terabytes of RAM
that. Yeah.
in 128 gig sticks.
Well, if you buy their server,
No, just one stick.
it's 96 slots. So that
So they have 96 128 gig slots.
That's literally
Yeah.
fast.
My website will not crash.
Huh?
How many
DUS.
how many gigs have you slapped though?
Well, so what do they say? You said 96 slots? 96 times 128 is 12, yeah, 12.2 terabytes. Why?
I wouldn't know DUS that.
It's like why?
it looks like that they put like 4 gigabyte pieces on the stick on both sides, and that's how they got it done. It's a bit taller.
Okay.
But yeah, it's
And then just wired it up?
Yeah, they just wired it up, I guess.
3D NAND gate.
For anybody wondering, the maximum RAM for Windows 7 that it can support, if you have home premium, was like 198 gigs. And for Windows 10 Pro, it can handle up to 512 gigs.
Oh.
So you can still use 128 gig sticks.
Yeah.
In Windows 7 and 10. I didn't check 8, but I'm assuming it's somewhere between that.
Sure. That's interesting.
Fun fact.
Yeah, what OS is going to support
Doctor's
our
already got it ordered.
what OS is we going to have that's going to support 12.2 terabytes? Samsung Linux. Yeah, that seems like an unnecessary jump. I mean, impressive.
distributed system for everyone.
The max.
It's an impressive numeric problem, but like, who could use?
Yeah, it seems like
Their
there's not a problem
transfer
with those
speed on
reasons.
that is like 3,200 megabits per second too.
Oh, so I can
Yeah.
see them you running a RAM drive off of it or something like that. So I mean I can see that being beneficial. So you're not really using it for RAM, you're using it for your kind of new hard drive. But even then, much more than 2 terabytes is going to be kind of unnecessary, right?
They just demoed a prototype for a 5 terabyte SSD they had
That's nothing. This is 12.2 terabytes.
with the same transfer speed as their RAM. So
I mean that's garbage. That's so yesterday. They were just showing a prototype. This place is shipping. Are they shipping us?
well, no, it's
It says
Samsung
mass
that had the
mass production ready.
It's what?
it's mass production ready.
Yeah, but what about their server? Are they still waiting on hardware for all the RAM slots? Do they have show a picture of this computer?
No, they just have the picture of the RAM stick.
Okay. I wonder what a computer that has 96 RAM slots in it. Like, what kind of physical real estate must that part of the?
That's where.
Or is it like something like super impressive, like they actually wire it in or something, and it's like the size of like the Mac Pros? Like really, it's an iPhone. We took an iPhone, we took one of those battery cases for it, and we made that all RAM. Okay. We miniaturized. We actually built a miniaturization machine. So we built the stuff, and it's like the size of a gymnasium, and then we shrunk it. We figured that was the most time-effective way of doing this. And we built the entire model, like, it's kind of like the Star Trek thing, except they did it off the Honey, I Shrunk the Kids movie. Totally worked. You saw that movie, right?
I love that movie.
Yeah, it's Rick Moranis still alive.
Yes, he actually, they approached him to see if he would do the new Ghostbusters, and he said no, but he didn't say he wasn't going to come back to acting. The reason he left was because his wife died of cancer. And he
Right.
raised his kids. Well, they're all fully grown now.
Why wouldn't he do the new Ghostbusters?
I can't remember what it was. It wasn't like he didn't respect the franchise. It was more of like he was passing the torch to the new people.
Isn't the I mean I don't know when it's officially supposed to come out, but aren't all the Ghostbusters now female?
Women, yeah.
Yeah, Because I guess because you had Egon died, and he was also the original producer, right? So did it just all kind of fall apart? Because I don't think Dan Aykroyd and those guys in the new one.
I think
They're like consultants or something like that.
Most of them cameo at some point.
Okay, the consultants.
Yeah.
Okay, so let's talk about multiprocessor scheduling, kind of just in general, because I want to kind of truck through some of this stuff. But one thing we kind of discussed was that scheduling for multiprocessors doesn't necessarily immediately make things faster, because we add more processors onto this and now things get more and more complex, right? So having a dual core processor doesn't immediately make everything twice as fast. It makes some things maybe 1.7 times faster, something like that, because you're going to have maybe 0.3 of those, the time units set for the overhead of scheduling. Now it's more complex to schedule for these things. Speaking of that, I think at some loose level this is related, but it's a cool technology story I read yesterday for improving the efficiency of boarding airplanes. I think I liked it on Facebook. I don't know if anybody read it, but the idea is that some of these new planes are going to have removable cabins.
Oh, I saw that. Yeah.
So and basically the plane itself will be a receptacle for a cabin. Okay, so you have various size cabins for the different size planes. And the cabins will live at the airport, and they'll preload the cabin. So you get to the airport, you can immediately take your seat, because you don't have to wait for the plane to be there as long as the cabin's there. All right, and what they'll just do is they'll rotate cabins. So plane gets there, they eject one of the cabins, lock it into the, maybe the terminal will have two, I don't know, cabin receptacles or something like that, and then drop the other one on, plane ready to go. Throw some fuel on it and get the new bags on, and we don't have to deal with the whole, the time period it takes to load people. They've already been preloaded. They probably even already have drinks and stuff. They've been like chilling for a little bit, and all of a sudden they're just told they're cleared for takeoff. Isn't that kind of a cool?
It's cool, but it seems like there would be a lot of moving parts involved that I'd be leery about.
Right.
I wouldn't be.
There's
too-
already
Maybe.
a lot of.
What kind of? Just Velcro. Wouldn't you be fine with that? They just Velcro the cabin on?
So long as Pinto doesn't, design it.
You got a guy just strapping it down with buttons.
You need a really big parachute for the cabin.
You missed one.
Well, that's another thing.
Yeah.
Is in the event of like an emergency, you could eject the cabin with a parachute.
And a flotation around the entire cabin.
Yeah, I mean this could legitimately be
Turns
kind of a
into a
cool
cruise
thing,
ship.
right? I mean, I do get what you're saying. I mean, is that
I think they would implement hella safety procedures. But I mean, the thing I see is this doesn't prevent me from then sitting in the airplane for an extra 4 hours instead of sitting in the airport for 4 extra hours.
Well, yeah, but the reality is that don't you hate when you like have there's like a busy flight and you can't find a seat like near your terminal?
Yeah.
Now you can just take your seat and start. You get your stuff in your overhead bins and everything.
sleeping.
Huh? Yeah, but hopefully then you won't get woken up when you hear that Velcro sound. So they might have to like reseat it a couple of times.
Or would it be like a kind of a traumatic experience to be loaded onto the next plane? Would that be scary for people, or?
Yeah, I don't think I don't think they're doing like roller coaster style. Although that would be kind of cool if it's like a lock-in effect. Like they have you up on this thing, you're level, and then they just drop you on, and then you hear the lock engage on the end.
My guess is it would be.
Huh? Yeah, that's true. Kind of like the Batman, the roller coaster, or like the Superman one. They actually have you.
And then they just slingshot the plane into the air now. They don't even need the plane, just the canister, just the.
Yeah, they just fire you.
Throw you.
Yeah, they're using missile launchers instead. Missile launchers and parachutes and cabins. It just saves tons on fuel. And they're using rifling technology, so it kind of throws like a football spiral.
This is a good plan.
Great.
We shouldn't be designing. transport, is what you're.
But think about the wait time. Think about virtually.
Yeah, it's kind of funny. All right, so punchline. I think that was related to what I'm talking about here, because there is
lines, yeah, we're talking about.
Yeah. So there's something, I don't know, it popped in my mind related to it. But in any case, one thing we want to, and this is related to this whole RAM thing, things we're talking about. So with great power comes great responsibility, right? So as we get more and more RAM, or as we get more and more cores, it increases the complexity of scheduling for these things. It increases the complexity of being able to address that much RAM. Okay, so now you've made your addressing protocol for your operating system more complex, which then translates into slower. Still might be fast, but slower. Are we willing to have a slower memory addressing protocol in place for a ridiculous amount of RAM, of which we will likely not use? I mean, you see the conundrum? At some point, we have to move ahead with more RAM, right? Although it does seem like we do need smaller segments here for our jump. So maybe this is more of an interesting server thing, and then there's going to be a consumer. So I can maybe see this type of example, like in server farms, like for Google, Amazon, some of the cloud computing platforms that could legitimately put some of that to use, because they're servicing thousands of simultaneous users, and these are cloud computing users where they're running multiple applications and stuff. So I could see it in that model. Okay, but for a consumer, in today's computing world, I don't think any of us could take up more than 32 gigs of RAM. And in my mind, I'm actually believing it's probably more like 24 gigs of RAM. But 32, by any definition today, I think is plenty, is the argument. So if we're going to take that next leap, I think quad 16 gigabyte chips, something like that, for mass market, maybe dual 16 gigabyte chips is $130, something like that. I can see that being viable to kind of keep us going for the next 5 years, something like that. But with something like this, maybe that's the catalyst that's necessary to make kind of the next major leap forward, because we are kind of due for a major leap forward in computing power. We haven't had one in a while. We used to have this idea that every year computing power doubled. We don't have that anymore. You look at your processor speeds today, they're basically identical to the speeds they were 7-8 years ago. Fine, the architecture gets a little bit cleaner, certain things speed up, they find ways of solving small sub-problems within computing. So for certain things, we're able to make them much, much, much more quick, or much quicker, most quickestly. So in any case, then we're also finding ways of leveraging our GPUs and our graphics processing, or graphics cards to make certain things faster, things like that. But those are for very tiny problems rather than a global increase in speed. So we are kind of due for something like that. So I guess this will be kind of interesting. But punchline here is, just like we can't clearly see a need for 12.2 terabytes of RAM. Do we really need more than even 8 cores? Do we need more than 8 cores for a majority of the stuff we do? Very specific tasks benefit from having more cores. Okay, but even within those specific tasks, there's going to be a limit. Like in here, I think I talked about video conversion. So in a video conversion type of example, and that wasn't here, right? We talked about that. Having more cores translates into being able to convert a video more quickly. All right, so something that might take an hour on a dual core machine, you can do in a couple of minutes on an 8-core machine. Goes a lot faster. Great. All right, because you can leverage those other cores to split that job up. But don't you think at some level you're going to start getting diminishing returns? As you have more and more cores, and that problem starts getting thinner and thinner, where you get to the point where every core is handling one frame of your video, where the overhead of communication between the cores outweighs the amount of time you saved splitting the work up. So with that in mind, there's going to be a diminishing returns for that kind of stuff. So, we're probably in a world right now where 8 cores, 16 logical cores with the super hyper-threading stuff is really going to give us the maximum balance between throughput and is it even worth spending the time dividing up the work, right? And even, let's take really, so several of us, I'm just assuming, have at some point in time downloaded a large video file. And you might have had to need to convert, you might have the need, to convert it into another format. Most of the time, what do we do? So most of our computers would take, an hour to convert it or something like that. Let's just use that as our baseline. Is that the end of the world? Do you just set it converting and go get dinner? Or go to bed? Who cares? I was going to spend 8 hours sleeping anyways. So it'll be done sometime while I'm sleeping. Who cared? We didn't need to go out and spend thousands of dollars on a machine that can convert something in 1 minute when we're not going to watch it till tomorrow anyways. Something like that. All right, so there is a point in here where things aren't necessarily practical or things we perceive to be problems aren't actually problems. Okay, so let's keep going through this. All right, that's stupid. And we alluded to this earlier in the semester, multiple processors versus multiple core processors becomes a power consumption thing as well as a communication speed thing. If we have 2 cores that live on the same physical chip, they're in closer proximity to each other, therefore they can communicate with each other more quickly. And some of that communication takes place with L3 cache. When we talked about that, that's for multiple cores to communicate with each other, as opposed to having physical separate processors where, so like our Mac Pro down the hall, I think we have dual quad cores in there. Maybe no, I think it's dual 6 cores. Dual 6 cores in there. So the 6 cores on each of the individual chips can communicate very, very quickly, and then the 2 physical chips can communicate fast but less fast. Okay, something like that. So we do still have travel time for those communications. And that travel time is obviously, from a human being's perspective, minimal. It doesn't take very long. It's some number of microseconds or nanoseconds or something like that. But I guess everything can be measured in microseconds. You just might get to really giant numbers. It's like, how long does it take you to get to Milwaukee? 75 billion microseconds. Ish. It's actually probably not even enough. It's like, what is 25 minutes in microseconds? That's gonna be on the final.
What is 25 minutes in microseconds?
1.5 e to the.
Let me think about that.
Yeah.
25 minutes converts to about 1.5 billion microseconds.
Oh. So I really gave about the distance to Chicago.
Yeah. A lot smaller number than I thought it would be.
Why is Siri able to convert from minutes to microseconds?
Wolf.
I think it's because Wolfram Alpha.
Yeah,
Wolfram Alpha can do it.
It popped up a little thing that said Wolfram Alpha too.
Okay, so whatever. Most of our machines today are multi-core processors, and then the server type things are multi-core and also multi-processor, physical processors. We already talked some about scheduling threads on our various cores. Again, this just adds complication to things, right? We want to have threads get as much CPU time as we can possibly give them, but not at the cost of things happening out of order and all this other stuff. So again, as problems get more complex, that doesn't necessarily, and we add these new features, that doesn't equate to faster performance. We do get diminishing returns because these problems are hard to solve. So virtualization and scheduling. So this kind of, we talked about this earlier in the semester. I think you had a paper on VMware and that kind of stuff. So the idea is now we have a software application like VMware, that's sitting on top of the host operating system, that is grabbing onto a couple of the CPUs as host CPU cores, basically taking those off of the chopping block for being able to be scheduled by the underlying CPU, or at least potentially taking them off the chopping block, depending on how you implement the virtualization. But let's just say that you have a quad-core processor in your machine, and you set up VMware, and you say you're going to give your VMware virtual machine 2 of the host CPUs. So now it's as if you have 2 dual-core CPUs, right? All right, and then maybe you had 8 gigs of RAM. You're going to give each of your operating systems 4 gigs of that RAM. So now it's like we have 2 computers, each running 2 gigabytes, each running a dual-core processor and 4 gigabytes of RAM. Is that going to be pretty decent? Is that a decent machine? Okay, if we take something like we had down the machine down there, we can give each host operating system, we can run the Mac and then virtually host Windows in there. And now we can have dual 6-core machines with, let's just give them each 8 gigs of RAM. Those are pretty good workstation level machines, right? All in one machine. Does that mean that each of those machines will run at the same speed as they would if they were native hardware? Why? What's going to be the slowdown? What's always the slowdown? Okay. Specifically with which communication? You take your computer, it's hard drive. You take your computer today, and that's why the war we're seeing right now is how do we get faster and faster solid state drives? Because right now the war we have is that the speed of the physical devices that are our hard drives are the slowdowns inside of our computer. Okay? That's where something like this 12 terabyte RAM system makes some sense for a server, because you could take a big chunk of that and convert it into a really, 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 really fast and a really expensive hard drive. That thing's probably going to cost as much as probably more than a house. I'm thinking a pretty decent yacht is what I'm really thinking about. Yeah, I mean, 12.2 terabytes of RAM. I said it would, so we have
1,000 times 96, so times 100, say.
Yeah, you're right. So a decent house at least. And then you have the hardware after that, and it's going to be a premium hardware to have that many slots. So yeah, maybe $500,000. Nothing, no big deal. Did you bring that Christmas tree with you, or was it already here? I bring it with me to every class. I set it up. You should totally do that. To bring that Christmas tree with you. No, I'm sure it is, but I mean, it would be a very funny joke, and you should probably still do it. At all? Today? Tomorrow? Okay, on Thursday, you swing by, you grab your Christmas tree, and you bring it with you to class. The teacher says, "What are you doing?" He said, "What, no Christmas cheer?" And you go, "Ho, ho, ho. Green giant." I'm sorry, Saint Nick.
He's been waiting a lifetime to use that one.
What, Saint Nick or the Green Giant thing? Whatever happened to the Jolly Green Giant? You guys know who I'm even talking about?
Yeah,
From the-
sexual harassment case or something.
Did they? That was when vegetable commercials were cool. The guy used to throw Brussels sprouts. Do you know he was from those, or you just saw him in some South Park spoof or something like that?
I thought he was just a bean guy.
Green bean guy.
Just green beans.
Yeah. He was a green bean.
No, he was
What
for the
company
company.
was he even for?
That's-
Oh, was it?
Wasn't it Green Giant?
Yeah,
Yeah.
yeah.
It was Green Giant.
Yeah.
That was the company.
Yeah, they make all sorts of different vegetables.
only saw
I think he used to harvest corn. Yeah, he did all sorts. That guy, I mean, he should have his own reality show.
They sent him into the field.
What's up?
So they didn't even need a harvester, they just sent him in.
That's right, exactly. Oh, you would have found this entertaining. Last night I had one of those the bird toys. It was playing with the cats, and I mean Gracie doesn't even use her paws. She just goes after it like a shark.
Yeah.
She just bites at it with her teeth. My big cat. I mean, cats usually they try to bring it to their mouth with their paw. She just goes after it with her mouth. There's something wrong with that thing. Okay, so hard drives are going to be our slowdown. So the best way to get high virtual machine speed is to have multiple hard drives in your computer and have the virtual machine live on that second hard drive. Or at least allocate its hard drive space on that second hard drive. That way you at least have a separate mechanical device under the hood for that second hard drive, for that second virtual machine.
Just have VR running the 12.2 terabyte.
Well, that's going to give you a substantially faster performance. I would say that a single core virtual machine running off its own hard drive will run substantially faster than a quad core virtual machine running sharing the hard drive with a host OS.
It's like question, what would be the point in having an external SSD?
Will be the point of having an external SSD
Yeah,
that
I
you
mean,
can't
would you be
put it
able to-
internally?
No.
That
I mean, what are the benefits?
you don't have to open up your computer and put it in there.
But you just connect it all the time?
Sure. I mean,
Slower.
you're also limited by the interface. If you have like an eSATA interface and it's the same speed as the internal serial ATA, then you're not giving up performance there. But if you're hooking up an external solid state drive to a USB port, you're wasting money. You're losing performance because the bottleneck's now your wire, your interface to that guy. But as long as you have, or what the Apple thing is, what the lightning cable, or is it Thunderbolt? Thunderbolt, yeah, whatever. They keep just naming things after storms, right? Ran out of cats, now they go with storms.
No, I think they're doing like Yosemite, because they did Yosemite and
National
then El
parks.
Capitan is like a lake in Yosemite.
Yeah,
And there's thunderbolts there.
you think?
I hope.
Or is it just their way of desensitizing us to the fact that we have to keep getting new cables every time we get a new device?
Next
So
up,
it is
Redwood.
Because even the lightning cables. So I mean now, like,
take out your USB ports and then they sell you an $80 adapter.
oh, for the micro or whatever their
USB-C.
USB-C, yeah. But yeah, like the funny thing is, so I've had every iPhone since they came out, but so the last several iPhones have had the lightning cable, right? Not all those cables are created equal.
No.
I cannot charge my most recent devices with a Apple certified cable that came with an older device.
What?
Mm-mm.
Dude.
Absolutely fact. Absolutely a fact.
Oh, yeah. I guess
They
my
must have
other
like
cables-
flipped a wire or something like that in there.
Is that with the new 6S's only then?
No, I've had
No,
this problem
so-
for at least 3 years.
What?
Yeah.
I mean, because this.
I want to say that the
6,
cable
I mean-
that came with, so let's see.
Are you sure it's not the charge block and not the cable?
No,
Yeah.
100% positive.
Because I've charged my 6 with 5S and 5 cables.
Yeah, and that might be true. So where I've seen it the most is a cable that came with an iPad. iPad 4th gen or newer will always charge everything. So it must be a higher grade cable or something like that. But I think what was the first lightning cable? 5? I think a lightning cable that came with a 5 would not charge my 6 Plus at least. Pretty sure of that. It definitely wouldn't charge my iPad Air. So
Well, that makes
there's
sense, 'cause
there's some
there's a
compatibility.
higher
But it's a
capacity.
lightning cable.
Well, the cable's is rated higher probably for the ones for the iPad. because
Apple
they take a
doesn't
bigger
sell
charge.
iPad lightning cables. They just call it the lightning cable.
Is it the block that matters?
I mean, because I plugged in all sorts of different stuff. Because you should be able to charge it off the USB port on your computer. It'll charge a little slower, but
I don't know.
yeah.
I've never ran that
it's a
problem.
proprietary issue with it.
I've never
More than likely, I'm guessing they flip a
flip a wire.
and then just change the output. So you get it and say, oh, well, this doesn't work. Well, come and give us another $30. They
Well,
just
I bet-
desensitize you. You bought it on sale, and then you have to give them another $30. Just kind of like the you used to have to buy, every time you've ever bought a printer, you have to buy a printer cable, right? Printers don't come with cables. So in the early days, you used to have to get the actual parallel printer cable, and those cables were actually fairly expensive to produce. Okay, but you still had to buy it, so you pay your whatever for the printer, and then $40 for the stupid cable. Okay, well now the companies are making just crazy profit. So you go into like a Best Buy, you buy the printer, so they have some markup on the printer, but not nearly as much as they have a markup on the cable.
We don't
Okay.
sell cables even for them anymore.
You sell USB cables for your
Yeah,
printers.
they come with them now.
Printers come with cables?
Yeah, because they're all wireless anyways.
That's just stupid.
They
Are you
just
sure?
marked up the crap out of
Oh,
the
they
ink.
marked the crap out of the printer?
The ink in some printers.
Oh, I see.
Really get you with the ink.
Yeah.
Because like that
Or
that
there's
US,
the new Epson that's like
that-
$500.
that USB
printer.
cable, you know, you would pay $30 for the thing, and it's like a 50-cent cable.
Yeah, it's like $5 now for that cable.
Hmm?
It's like $5 for that cable now.
Maybe probably it was the online market that started driving those things. People can go online and get the printer cable for 30 cents. You know, well, it just made sense to get the 12 pack. So I bought 12 USB cables for $5 instead of one for 30 cents because shipping was just too much. And then what I did is I returned the rest of them to Best Buy and made profit on the printer. They got store credit, but yeah, allowed me to buy my new TV. I leveraged my new TV through returning illegally purchased, well, not illegally purchased, returning USB cables that were not purchased from Best Buy to Best Buy for store credit. It's a good plan. Christian worldview. All right, so virtualization does throw an impact on scheduling because now we're taking some CPUs out of play. And scheduling can now be applied to a lot of different things. We're going to try to get to file systems and stuff as well before the end of the semester. So I'm trying to cook through these a little bit. But, you know, the idea is that the second we put more, the second we start sharing resources among more interested parties, scheduling becomes more difficult. Okay, not important, not important, not important, not important, not important, not important. So this is just their different takes on how these things happen. They use different time quantums. Done. Okay. Okay, so how to select CPU scheduling algorithm for an OS. So the starting punchline for this is what we've already talked about is it's kind of a crapshoot, right? And some OSs have built into them the ability to kind of tweak themselves based on how the user uses the system. I think I probably used an example in class about how we've seen this with some of our mobile devices now. You know, every time I get in the car at Concordia, it assumes I'm heading home, so it tells me what the what the time to home is and that kind of stuff. You know, the idea here is that at the end of the day, it's an evolving type of approach, I guess. You know, what scheduling algorithms we use. How do we determine the criteria for the algorithm? Again, it's a crapshoot. You know, we're hoping that there's some underlying pattern how human beings use their operating systems, and those patterns give us some information about how we need to schedule things. But at the end of the day, different users might use the thing differently and might get different, you know, results may vary or something like that. So let's just say that's the punchline there. Same thing with queuing models. What's the best way to kind of stage our processes for getting CPU time? How many priority levels do we use? How many different queues do we use? How do we treat our threading queues? You know, you can just roll the dice and pick it and probably not experience a significant performance difference 80% of the time. It's that 20% of the time that's very specialized that might make a difference. That's why we've kind of mentioned historically that the differences between our consumer level operating systems and our server level operating systems might be that initial guess that they make on how is this machine likely going to be used, that type of thing. Yeah, so like they're talking about here, arrival processes, CPU and I/O bursts probabilistically. We can have commonly exponential and described by mean models for the queue, compute average throughput, utilization, waiting time, etc. So now we're like keeping statistics on the various jobs that are in the system based on their current experience and making little tweaks as we go. That's all fine and dandy, and it's going to be relatively customized to that particular machine and how things are being done on that machine. But what if you have a single day where you use your computer much differently than another day? So let's say there's a day where your computer is just in convert illegal video mode. All right, so your machine's just sitting there for 18 straight hours converting videos. and all of a sudden you have all of your scheduling stuff get modified. All the variables get jumbled because your performance had the way the computer was being used was different. Well, so now you're going to have you're going to experience the potential sluggishness, or at least differentliness, later on until it kind of bounces back to normal. You might notice it, you might not, but the change is still there. Computer system described as network of servers, each with queue of waiting processes. So when we say network of servers, we're really talking about the various resources that are being shared in our computer system. So each one of those resources has a queue or some sort of line to, who gets access to the hard drive, how many people have access to the hard drive, who gets access to the RAM, so on and so forth. Knowing arrival rates and service rates. So how often are things requesting the hard drive? How often are things requesting the RAM? How long on average does it take to handle the requests that they were asking for? All these things play into us tweaking the algorithm. So having a set algorithm that just works is almost an impossibility. Okay? Yeah. Little's formula. Very interesting. I've never heard of this. Average queue length, average waiting time in queue. Yeah, stupid. Completely useless. This is just a guess. It's probably one of the author's friends or something. So, one way we can kind of tweak this is through simulation. So I've kind of talked about that. Your operating system can make changes based on how you're using your system, but that's an over time type change. Where if we can create, quote, realistic simulations of how consumers may use an operating system, we can expedite that by, basically bombarding the operating system with real-time usage in a very compressed period of time. Allowing it to make those changes. Maybe it's they can feed the algorithm. So it would probably be some sort of based on artificial intelligence, an evolutionary type algorithm that literally gets fed hundreds of years worth of user data in a very compressed period of time, and then adjusts all the little variables. And we've basically said, okay, we've tuned this based on our guess at how human beings will use this system. Let's hope that the nature of computing doesn't change or that our guess was right. That's basically what I just said. So even simulations have limited accuracy. So just implement a new scheduler and test in real systems. So what's the high cost, high risk? Various environments vary. So just because we run a simulation for a specific environment that we guess that might be completely different than another environment. So it's still all a crapshoot. And really where this has the biggest difference is, do we use the same scheduling algorithms on mobile as we do on desktop? Probably not, but maybe so. Maybe we wouldn't notice. But certainly on the desktop side of things, we certainly wouldn't take power consumption into any consideration when writing a scheduling algorithm, right? Okay, because scheduling algorithms in general, we wouldn't say have a major impact on power consumption. When you talk about your electrical bill at the end of the month. But now on mobile, everything has to go through the filter of power consumption. Doesn't matter what it is. Doesn't matter how little it might be. Everything goes through that because one of the things we're trying to maximize is battery life. So that's now a new variable we throw in there. It's like, okay, well, we can give the user a little bit better performance, but will they notice? Well, they'll definitely notice the battery life is now half. Okay, so now these are decisions that have to be made.
Android, we'll just put a bigger bag.
That's right. Most flexible schedulers can be modified per site or per system. A lot of them have it built into that where they just try to make smart decisions. Or they do have APIs for modifying priorities. We've seen that in Windows where you can go in and say, I want this guy to be more important than he was before. Lets the user make some decisions. But again, environments vary. Like we had to be reminded of that. Okay. It's interesting that it would say end of chapter 5 and then go on with stuff.
This is just all pictures.
They put the slide. It says they introduce us to new dinosaurs coming soon in chapter 6. Okay, so yeah, this is just showing CPUs talking to each other.
It's just all pictures.
Yeah. Java thread scheduling, time slicing. Right, perfect. Okay, so what I'll do is I'm going to put up a homework assignment for chapter 6, give you like 2 or 3 questions from chapter 6 just to kind of get you starting reading, and we'll start chapter 6 on Wednesday. Sound good? All right, I will see everybody then.